The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, ladies and gentlemen. Welcome to TechGig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we've initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Introduction to AWS Architecture. Our guest speakers today are Anurag and Rajat Toshiwal. Rajat is a data architect at OSS Cube Solutions Limited. He has broad and deep experience in Linux server administration and architecture, designing and deployment on cloud. He has more than 9 years of experience in server administration with proven expertise to increase reliability, maximize productivity, and introduce overall system efficiency. In the past, Rajat has worked with Simon, TechMinds India, AFL and Progress Software with major focus on server architecture and communication, databases, IBM products, and Linux servers. AWS has been his major interest. He has very strong background in AWS managed services, consulting, and performance optimization. We also have Anurag with us, who takes care of business development initiatives at OSS Cube. So without further delay, I introduce you all to our guest speakers. Over to you, Anurag.
Thanks everybody for taking time out of your busy schedule for this webinar on AWS. I will introduce OSS Cube. OSS Cube is a leading global open source software focused company providing an integrated value chain of services encompassing outsourced software product development, product customization and implementation, along with the consulting and training services on open source product and technology. We work through our principal locations spread across North America, the UK, and India. We are CMMI level 3 accredited organization, and we believe in continuous delivery for fast and predictable projects. To consistently deliver efficiency, excellence, and innovation for our customers, we work closely in partnership with the leading open source technology providers. To name a few, PHP, we are the world only Gen Center of Excellence. Sugar CRM, we are the platinum partner for Sugar CRM. We also work on Drupal. We also work on the PIMCO, which is the product information management. We are also in the Magento for the e-commerce solution providers. Along with that, we also work on BI data integration like Pentaho and Talent. And we are also Cloudera training partners for last 4 years. And we do training on the Cloudera training offerings with developer, administrator, Spark, data analyst. We also have a strong competency on MySQL and MariaDB. Along with that, we are also the AWS Advanced Tier Consulting Partner. OSS Cube has a broad set of competencies, but our greatest strength and what separates us from other open source solution providers is the ability to integrate many applications, as you can see on the screen, like Magento, PIMCO, Acton, to integrate into a solution that can help you to meet your business objectives, and clients can differentiate themselves from their competition. Talking about OSS Cube Cloud Services, our services are we are into AWS support, we give managed cloud services, we are into AWS consulting, and we do a lot of AWS performance monitoring. In AWS support, we give all types of AWS support needed to build, deploy, and scale your mission critical application on Amazon Cloud Platform. Our support services is specifically designed for enterprises to successfully utilize the products and features provided by Amazon Web Services. In OSS Cube Managed Cloud Services, we manage your application on cloud, we manage your modern application infrastructure for seamless experience. We work on the boost scalability, and we get the scalability of your enterprise tuning to IT demand, serving around million to 10 million users. In AWS consulting, we help organizations from building AWS cloud solution strategy and roadmap, performing risk assessment, and managing AWS environment to save cost and time. We are also committed to building the right solution that protects your critical infrastructure. In performance monitoring, we work on with clients identifying the best strategy for your needs. Our expert consultants on AWS provide clients holistic end-to-end monitoring solutions for highly scalable and highly available application and system. After this overview introduction, I will like to pass on to Rajat for the webinar on the AWS. Thanks everybody, and overall to Rajat.
Thanks, Anurag. Hi, everyone. Welcome and thanks for joining us in this webinar. So I'm Rajat Toshiwal and I'll be your presenter during this session. So in this session, we will discuss about AWS services, introduction of AWS, what exactly AWS is, what are the key benefits, key features of AWS. Then I'll give you a brief about the services which AWS has, some of the services which are very commonly used. Then we will discuss some of the use cases. So it's a brief introduction about myself. I'm working as a database data architect with OSSU. Bachelor, I did my engineering from PIT. Then I have 10+ years of industry experience in multiple domains. So it's like AWS consulting, database administration, Linux administration, and then networking. So let's see. So these are the objectives. What exactly is the cloud computing? Then introduction to AWS. Then why AWS? So in this we will, in this particularly we will discuss about the key benefits of AWS and the edge which AWS has over its other cloud competitors. Then we will, common use cases. In this we will see how people are using AWS. So we will discuss some of the use cases. Then how can I use AWS? In this I'll tell you how you can create account AWS and start using it. Then I'll provide you some pointers so that you can get into it. Then AWS Cloud Platform. Here we will discuss about some of the commonly used services of AWS. So the last will be the question answer round where I'll try to answer your questions. So by the end of this webinar, you will be able to identify where exactly you require AWS services. Then you yourself will be able to do this little bit of designing, the architecture designing of AWS. So first of all, let's discuss what exactly led to the arrival of cloud computing, cloud virtualization. So let's discuss the conventional approach first of all. So the broken plane here is symbolizing the broken infrastructure, which was a case which happened very openly with the conventional approach where you yourself is maintaining your data center. So it's actually really very difficult to maintain the data center yourself. Reason being, you require a lot of infrastructure, lot of investment in order to maintain the thing. Then you need expertise of all the platforms, like if you are running databases, if you are running application servers, then besides that you need the data center experts, physical security experts, surveillance systems. So it's really difficult for medium and small size industries especially, in order to do this much of investment initially. So in order to avoid such scenarios, what exactly you need? You need the infrastructure in right hands. In right hands, I mean the people who can care about your business. Then you need a brilliant and innovative minds in order to run this. So the people who can continuously do R&D or can update themselves so that they can incorporate the new products in order to within your infrastructure in order to streamline the overall process. Then you require a good investment if you are into the conventional approach, then definitely you need a team which can make your system 100% available. And friends, believe me, it's really a difficult thing to get the 100% availability. If not 100%, it's also challenging to get 99% of the availability. And the reason being, let me give you one example. Suppose if you want to host a site for your company with load balancing and load balancing and disaster recovery. So in that case, you require at least 2 application servers, 2 database servers, 1 load balancer, huge storage, and then 2 different physical locations. So it's actually difficult to maintain so many things. I mean, this is one-time cost which I'm telling you. Then in the recurring cost, you will have bandwidth, power, then your resources in order to maintain such service. So it's a huge, huge investment. Now let's see what all are the major bottlenecks of conventional approach. So first of all, disaster recovery. As we discussed, it's really difficult to maintain the disaster recovery or business continuity. Next is your capacity planning. I still believe it's quite a challenging task even for experts. Reason being, your traffic is not uniform throughout the day. Then if you are purchasing any server, you have this thing in mind that you will at least run your sites on this server for other 3 years. So it's really difficult to anticipate that much of traffic which will come over the years. So most of the time this led to the either the overutilized or the underutilized resources. Then AWS has a solution for this, and they have come up with auto scaling, a feature called auto scaling. Now what exactly auto scaling is, you can do the horizontal scaling whenever it is required. So let's say if you are running your normal site with two servers, then between 2 p.m. to 4 p.m. You have a peak traffic time, and at that particular moment your server's CPU utilization or memory utilization crosses the threshold, say 90–95%. So at that point of time, what auto scaling will do is it will create more instances for you so that the load can be balanced and the performance can be enhanced. And once that period is over, between 2 to 4 p.m., it will come back to its normal configuration of 2 servers. And the best part is, this all is happening automatically. There is no manual intervention at all. Similarly, the other bottleneck is budgeting. So as we discussed, you require a lot of budget. Then, yes, bandwidth planning. This is again a tedious thing to do. No matter how optimized your application servers, your database servers are, but if you do not have the proper bandwidth or if there are glitches, then the overall end user experience will be very bad. I mean, and that is something which companies nowadays does not want at all. Again, you need to have bandwidth from multiple ISPs also in order to have the redundancy. Similarly, power planning, you need lots of backups, lots of UPS in order to maintain your service continuity. Then the data overflow, that is where your storage comes into picture. So again, you need a lot of storage, especially if you are in the insurance sector or in the telecom sector, where as per the regulatory, you have to maintain at least 5 to 7 years of data. So there again, you need to purchase lots of SEN devices, then you require SEN experts. So overall, it's really very cumbersome and tedious process to manage your own data centers, especially for these small or medium-sized companies. So let's see how AWS can fix it. So what exactly is cloud computing? Cloud is really a real buzzword. Nowadays, everyone talks about cloud, but believe me, very few of them are aware how exactly they can use cloud virtualization so that they can be benefited. I mean, cloud provides multiple services, but before using it, you need to identify the challenges in your infrastructure and the criticality of your application. Then it's difficult to define in words what exactly cloud computing is, especially if you are talking about AWS cloud, because it's not only infrastructure which you will get on AWS, you will also get the ready-made applications. So suppose, you will have database applications, caching engine applications. You will have the almost complete big data setup there. It's just few clicks of your read. So you need not to do any kind of deployment in order to use this service. And the best part is all these services are highly optimized. So the optimization process actually does not take much time. Still, we have tried to create a definition for cloud computing. So it's a framework designed over an integrated gigantic network of remote servers and applications on internet outside your office premise to store and deliver information. So here the main point is the information. It's the information which requires this kind of setup for which you are doing all this. And the best part with cloud computing is you are paying for whatever you are using. So in my previous example of capacity planning, we have discussed about the two instances which gets generated during the peak hour time. So you will only pay for those 2 hours for those two instances. Now I have included a slide to tell you about the cloud flavors. Right now, 3 flavors are there. One is SaaS, PaaS, and IaaS. SaaS is software as a service. Now here everything is managed by vendor, and you need not to do anything at the application end or at the infrastructure end, since you do not have any kind of visibility also. So the best example of this is Gmail, where you are utilizing the benefits of the application. Jira is another example. So in PaaS, which is platform as a service, you have a shared responsibility kind of model where you will be responsible for your application and data. Whereas for rest of the things, whether it is operating system, runtime, middleware, virtualization, servers, storage or networking, you are not at all responsible for this. That all will be managed by your vendor. And the best example for this is Windows Azure. If anyone of you has used it, where you do not have the access of operating system, but still you can deploy your application or data via APIs. Then you have infrastructure as a service, where again you have a shared model, but this time your responsibility is much more than what you have in the past. So this time you're responsible for operating system, middleware, runtime, data, application. So with responsibility, you also get the flexibility. If you want to install any particular application over this operating system, in that case, it's pretty much easier for you because you do not have any dependency and have the complete control of your operating system. So the example here is EC2 instances provided by AWS. Then the last one is the infrastructure which you manage, and you are responsible for each and everything here. Let's move to others. Next slide. So it's introduction to AWS Magic Cloud. So AWS provides reliable, scalable, and inexpensive cloud computing services. We will discuss each of these terms in details in the later slides. Now, it offers a complete set of infrastructure and application services that enables you to run virtually almost everything. So if the application is not provided by AWS, even then you have a full control over the instances and you yourself can go and install those applications. So in 2006, AWS began offering IT infrastructure services to business in the form of web services, and from there they take off, and right now they are the #1 cloud virtualization cloud service provider, and now hundreds of thousands of customers have joined Amazon Web Services. And it's pretty easy for new startups especially, because they do not need to make huge investment in order to procure their infrastructure. And probably that's why more and more new startups are coming into picture. Then number of offerings which AWS provides, and they are continuously working to increase it. And these are increasing day by day. So this is the cloud rainbow. What all are the benefits of AWS? So let's discuss them one by one. First is scalability, experience, reliability, elasticity, easy to use, secure, it's cost effective. So this slide will have the answers for all the drawbacks of conventional approach. So we have already discussed the features like auto scaling and elastic load balancing helps you to up and down your servers and application on demand. Overcome the traditional approach of capacity planning. Before this, capacity planning was a huge challenge even for experts. And yes, of course, you can provision more hardware based on hourly traffic distribution or for seasonal applications. Then reliability. So AWS has multiple data centers in different regions worldwide. So regions are geographically segregated locations. So they have their data centers at multiple locations, and if you have designed your application properly, so even if one of the region is not working, you can access your application, or your customers can access your application via other regions. So as per the cloud reliability rating by Cloud Harmony, AWS tops the list. So this is the downtime in hours which all these cloud providers had in the previous years. So if you see, it's only 2.41 hours for AWS, and it was also not a complete down. So it's the aggregation or summation of the downtime which different data centers had in the previous year. So your application, if it is running across multiple data centers, then the chances of getting down is very, very, very less. And if you talk about the services like S3, which is a storage service, AWS provides 11 nines of reliability. So it's 99.9999999%. Now let's see the flexibility. So AWS provides a wide range of operating systems, programming language, web applications, platform, databases. You have MySQL there, PostgreSQL there, SQL Server, Windows SQL Server, Oracle services, whatever you need, you will get there. In fact, they have a licensing contract with Windows. So even if you do not have the license, which is for Microsoft SQL Server, which is very expensive, you can use it on AWS with pay-as-you-go model. Flexibility to provide cloud services for customers in diverse industries, from media to manufacturing and online retail to oil. So they have, in the past 10 years, built the capabilities for most of the industries. Now the flexibility allows you to focus on innovations rather than infrastructure. Very well said. So now you need not to focus on infrastructure because it has been taken care by AWS. You can focus on your business innovations. Enables you to quickly respond to changing market and opportunities. And finally, AWS provides you the flexibility when provisioning new services. Instead of the weeks and months to plan and deploy, now you can simply sign up for AWS and immediately begin deployment. So now you need not to go the long chain of approvals in order to procure any system. Within few clicks, you'll be able to do it on AWS. Low cost. So it's the primary reason why more and more startups are getting into it. Then it's a pay-as-you-go model. So exactly what you are using, you are paying only for it. Then save more as you use more. So this is applicable for the services like storage. So they have different pricing models. If your requirement is up to 10 terabytes, then the pricing will be different. If it is more than 10 terabytes or between 10 to 20, so there are multiple options. Then you can maximize your ROI. It's return of investment. Then there are multiple pricing models. So by multiple pricing models, we will discuss it later on in the coming slides. Then you have AWS free tier. I'm sharing the link for AWS free tier, and you can go and see what all you will get free if you are first time creating your account on AWS. Security. So a few years back, it was a major concern for most of the industries whether the cloud is secure or not. But now more and more companies are moving on to cloud, and now in fact the government industries, they have also come up with their applications if they want to host on cloud data centers. So data centers are staffed with 24/7 by trained security guards, multi-factor access control systems are there. Then they utilize the state-of-the-art electronic surveillance. Environmental systems are designed such that to minimize the impact of disruption to operations. Then, as we discussed earlier, also multiple geographical regions and availability zones are there. So if even if one of the data centers and one of the availability zones goes down, in that case you have the option of second. Then there are built-in firewalls. They also provide you the security groups through which you can control the complete access of your instances of your application. So you can allow which all ports you want to open, and to which all IPs. Then you have AWS Identity and Access Management System. It's the security over the console provided by AWS. Besides that, if you are using APIs or CLI, then you can control the access via the AWS Identity and Access Management. Then there is private subnet. It's actually VPC, Virtual Private Connect Cloud. So it's pretty much similar to VPN, and if we get time by the end of the presentation, then we'll discuss it. We'll definitely discuss it. Then you can encrypt your data storage. Now, this is how can I use AWS. So first of all, we have provided the sign up link, so you can go there. And I have mentioned the complete step-by-step process in the next 2 slides, which I'm not going to go through. But if you need any help in that case, you can consult these 2 slides. Then, if you need any consulting, then there is a link provided below, and there are other links also, which will help you to start with AWS. Now let's see the common use cases where exactly the customers are using AWS. So these are the most commonly used cases. So it's application and web hosting, which we will discuss in detail. Then you have backup and recovery solutions. Then archiving, since storage is very cheap on AWS. So if you talk about S3, the storage is $0.0 per GB per month. So even if you have 100 GB or 1000 GB of data, you will be charged only $3 or $30 per month. Then people are using it for disaster recovery. So they run their setup from their local data center, but they have VPC kind of connectivity, VPN connectivity to AWS cloud, and if their physical or local data center goes down, in that case the workload shifts to AWS. Then companies are using it for development and test environment, big data solutions, hybrid environment, which is again pretty much similar to your physical data center and the cloud data center. Then e-commerce sites are there, mobile services, content delivery, and gaming. So bottom three services are very frequently used nowadays. So let's understand the services provided by AWS Platform. So these are the various services. We will discuss them. So the bottommost layer, it is showing the region, availability zones, and edge locations. This is the physical setup which AWS has. The layer above it, it's the foundation services. So these are the services which are required, very much required to create any kind of designing, architecture designing. Then you have application services to support your foundation services, and at the top you have deployment and management. So these are the tools which are required for DevOps, or in order to automate your complete environment. So in this tutorial, we will majorly discuss on foundation services and the bottommost layer. Regions and availability zones. So AWS has 10 regions. By 10 regions, I mean 10 different geographical locations where they have their data centers set up. And within each region, they have multiple availability zones. Availability zones are again a different location, but they are within the same region. So the segregation is like within regions you will have multiple data centers at different geographical locations. Then you have 50 plus edge locations. So edge location is something which is related to CDN, the Content Delivery Network. So these are the endpoints from where actually if you are using CDN, then these are the points from where your content is getting delivered. So it's always better to host your service in a region where you think you have the most number of clients or customers. So if you have any service specific to US, in that case, you can host it in US East or US West, so that the proximity will not be much, and the overall bandwidth, you do not require the much bandwidth. So these are the AWS regions and availability zones. You have regions in US East, North Virginia, EU Ireland, Asia Pacific Tokyo, US West Oregon. China, it's in beta phase, so it's not visible there at console, AWS console. US West, Asia Pacific, Singapore, AWS Go Cloud. So again, this is also not visible since it's US government, some of the US government projects are running on this, and this is specifically for them. Then you have South America, Sao Paulo, and Asia Pacific, Sydney. So this is the segregation of AWS regions and availability zones, and it is very much important to understand this thing in order to create or design any kind of architecture, because you have to include both these entities if you want to have high availability solutions. So now side by side, we will also discuss the application and web hosting. So what this slide is showing is AWS regions, and there are two availability zones, availability zone A and availability zone B. Now we will include these services in this. So first of all, it's Elastic Cloud Computing. Elastic Cloud Compute is exactly same as your servers. So you will be able to do most of the things which you are doing on your servers, since you have the full control, complete accessibility of operating systems. So if you want to install applications, if you want to deploy any kind of data, code, everything is very much possible with Elastic Cloud Compute. Then the best part is it's resizable. That is, vertical scaling is very much possible. So if you are running with 3.75 GB of RAM and one CPU, and at one point of movement you think that this is not sufficient, and you require more. So in that case, within few clicks, you will be able to upgrade that particular instance to next higher level or to any of the other instances. Then, as I said, it's completely controlled. We have already discussed the auto scaling thing. Then the pricing models. This is the flexibility which you will get. So if you know that there is one particular site which will run at least for a year or 3 years time, then you can have a kind of agreement with AWS. And what AWS will do, that AWS will provide you the services in much cheaper rates. So there are 3 kinds of pricing models with EC2. One is your reserved instances, pricing model for reserved instances, pricing model for spot instances, pricing model for on-demand instances. So I'm talking about reserved instances right now, where you need to give one-time upfront cost and then your monthly or the hourly charges become very less. So it's much more cheaper than the on-demand. What we have in on-demand is if you are not very much sure that this particular application will run for a year or not, or if you are doing doing any kind of test run, in that case you can go for on-demand instances, where you will be charged on hourly basis. All spot instances are the cheapest one, but you do not have the control over the termination of those instances, since it very much depends upon the bid system. Then EC2 service level agreement commitment is 99.9% availability for each Amazon EC2 reason, which is really huge. So now, where you will put these EC2 instances? So you have regions, then 2 availability zones. So within each availability zone, you will place 1 EC2 instance. AWS Security Group is a kind of firewall from where you can allow the ports and IP addresses which you want to. Now, next in this category is you need to distribute your traffic over these 2 instances. So the application which you will use for this purpose is Elastic Load Balancer. So what exactly Elastic Load Balancer is, you can distribute your traffic across zones. So it's across zones. If you want to have it across multiple regions, in that case, there is a different service which is known as Route 53. So you can deploy that. So that will do DNS load balancing kind of stuff and share your overall traffic across 2 regions. Then ELB can detect the health of Amazon EC2 instances. So if any of the instances is not working properly, then it will automatically move all the traffic to the healthy instance. Then SSL offloading is there. That is, you can configure SSL certificates over your load balancers. Sticky session is there. So even if your application does not have, in that case, you can utilize this. But it's always better to have it in databases, these sessions. Then you can have layer 4 or layer 7 load balancing. So you can do the load balancing on HTTP as well as on TCP. Then if you want to see what all kind of traffic is coming, you can enable the logging. And if you want to see the distribution, then also you'll get that information. So now we have Elastic Load Balancer at the top. And what exactly it is doing, it is distributing the traffic between the 2 instances. Now, next in this category is RDS. It's Relational Database Service. So as I said earlier also, you have MySQL, MS SQL, PostgreSQL, Oracle available. Now it's again very cost efficient and resizable. By resizable, again, if you are running with a smaller instance, you can opt for medium or large instance whenever it is required. So vertical scaling is very much possible. You require less management since these instances are already optimized. It happens very rarely that you need to change the configuration parameters. But yes, it very much depends upon your application. There are few scenarios where you have to do this. Then These services are fast, predictable performance. Then there are again multiple pricing models. If you want to have reserved instances similar to EC2, in that case you can go for, which are much more cheaper than the on-demand instances. Yes, of course, you will not get the on-spot kind of thing here in RDS. You know, multiple families are available. So if you want to have instance with high memory or IO intensive, or if you want to have instance with high CPU, then that all is available within this. Then it comes with multi-AZ. Multi-AZ is multiple availability zones. So what happens in this is you will run 2 database instances, each in different zones, but at any point of time you will only have control over one, since you can only interact with one of the database, the master one. So if master goes down, in that case your slaves come up and take the master's position, and it all happens automatically. Amazon RDS for MySQL and PostgreSQL now support encryption at rest. So it's on the fly masking kind of stuff. I have not so far used it, but it is still there. And a read replica. So another thing in this is read replica. If you have designed your application such that you can distribute your write and read requests, in that case you can go for read replicas. So where we will put it, now and again 2 availability zones. One database is acting as a master, another one is as a slave. Now all the requests will go to the master MySQL database. In case if it goes down, then the slave comes into the picture. Another component is ElastiCache. So in this, Memcache and Redis are the operands. So this is we generally use to reduce the latency. Since all these are memory caching engines, or otherwise they store the key value thing within a particular part of your disk. So it's always easy to go and check that particular piece of disk. So they are much more faster as compared to your databases. So Amazon ElastiCache automatically detects and replaces the failed nodes. Suppose if you are using the cache cluster for Memcache or Redis, and if one of your instances within the cluster goes down, in that case it will automatically detect it and will not send further request to that unhealthy instance. Then again, multi-AZ is there. So if you want to have your service in multiple availability zones, you can very well have. Now where we place it, it's before MySQL database. So now all your requests will come to the cache engine, and if the data is present there, in that case it will be served from there. Otherwise, the request from cache engine will go to your database, and then your database will feed the cache, your cache engine, which ultimately will feed your instances. So again, you will have the multiple variety of instances in terms of resources, in terms of RAM and GPU. So you can opt as per your requirement. So we are actually almost done with this setup, but again, this is EBS. So if you are not using any block storage with your EC2 instance, then the default storage which comes with your instances, it's like RAM. It's an instance store, which if your server gets terminated, in that case all your data will be vanished. So if you want to have durability, or if you have any server where you want to keep that server down, but you want to have the accessibility to data, in that case you can use EBS. So even if you shut down you terminate your instance, your data will be intact there in EBS. Whenever you want to retrieve, you can create another instance, associate EBS with that instance, and then mouse it, and your data will be there. Then it is automatically replicated within its availability zone. So within our availability zone, there is no way to replicate it across availability zone. If you want to do it, then you'll have to do it by yourself. There are multiple applications running like rsync and all. There's consistent and low latency performance. It's highly optimized in terms of IOs, and it provides different volume types, like you have the magnetic, general, or the provision IOPS. If you have a requirement of more and more IOPS, in that case you can go for the provision, and you can get up to 128 Mbps of throughput from one EBS. Then point-in-time snapshots are available. So this is a backup mechanism, so through which you can take the snapshot at any point of time of your complete EBS, and then EBS encryption is possible, but that is again which is not provided by AWS. You can very well do it. So now we have placed EBS with EC2 instance, and the infrastructure is almost ready. The only thing which is left is the monitoring. So AWS provides CloudWatch in order to monitor all your services. No matter whatever applications you are running, you can check the metrics of all those applications, but then you have to customize it a little bit. Then you can very easily track resource utilization, application performance, and operational health. And CloudWatch is something which is used by auto-scaling also in order to trigger the instances at high peak traffic time. So this is where you create a check. First of all, suppose say if your CPU utilization goes above 90%, in that case other instances will create. So this is the utility which actually triggers auto-scaling. Then you can see the graphics and statistics. So it will provide you the complete graphical information about your about the metrics. Then trigger alarms based on tracked metrics, so you can get email or the SMS notifications. Then custom metrics are also supported. So now let's see. So now instead of EC2 instance, you have instance with CloudFront. So now we are doing the monitoring. Similarly, CloudWatch you can also utilize for database monitoring or the cache server monitoring. So right now we are done, and now I believe you are ready to take off your flight in cloud. Thank you so much. This is a question answer song. Let me take your questions.
Thank you, Rajat. Thanks for this insightful presentation. Let's quickly take up the questions now. I would request you to read out the questions and their answers.
Sure. So the first question is from Mr. Saurabh Kumar. Is it good to expose DB server and application server to outside world with Linux root user? If not, which is the best approach? So as far as database servers are concerned, you need not to do it, since the database servers need to be exposed only from application. And if you are running load balancer, in that case, the only access to your application is via, you require only load balancer access via to your application server. So load balancer is there, then you have multiple application set, then you have the database layer. So the application can access your database, your load balancer can access your instances. That's it. If you want to allow your public static IPs, fair enough, you can do that if you, in order to do any kind of testing. Now the another question is it possible to group multiple EBS to act as a single storage for EC2 instance? It is from Santosh Kumar Varla. So yes, it is very much possible. So I think you can add up to 10 terabytes of, 10 10 EBS instance, each of 1 terabyte. So that overall limit will be your overall limit of your EC2 instance will be somewhere around 10 terabyte. And it is actually good practice also if you need more IOPS. So as I said in my presentation, you can get the throughput of up to 120 Mbps. But if you want more, then definitely you can have multiple EC2 instances and very much RAID kind of configuration you will create, so that your overall IOPS will increase. Now, so the next question is from Mr. Vinay Mehta. Do I plan my own setup for a DR site or plan it in a different AWS zone? Which will be better and cheaper, assuming that in very rare instances I would need a DR with AWS as primary provider? So Vinay, if you are not using AWS, in that case you will have to purchase the infrastructure equivalent to your primary, and if not equivalent to that, so at least half, in that case half of the capacity is required. So I believe it's always better to go with Amazon because it is much more cheaper. Your investment will reduce by at least 1/4 per year, and then again the maintenance also. So same question is asked by Ratan Das also. How about DR and AWS? Yes, it's a very good idea. You can use the services like VPC. So what it exactly does is it creates a virtually isolated cloud between your data center and the Amazon cloud which you have. So your whole communication will be completely, your whole communication is very much secure. And again, you have multiple options available on AWS. You can create your private or public subnets. Public subnets are those subnets from where the instances can interact with internet directly. So, and the private subnets are the subnets where you put machines which you do not want to interact with internet directly. So the previously asked question whether I expose database to public or not, this is also the one way to secure it. Can we use custom load balancer like Nginx? Yes, you can definitely use that, but again, in terms of reliability, it is always much better to use service provided by AWS. The benefit here is they have a kind of redundancy set up within their availability zones for each and within their availability zone or across availability zones for their services. So in case you are going with Nginx as a load balancer on one of your EC2 instance, and if it goes down, that will it's a single point of failure actually. So it's always better to go with a service which is much more reliable in that terms. Kindly guide how SSL integrates on a website. So if you are talking about load balancer, then it's fairly a simple mechanism where you need to only import your certificate chain, and I mean you need to configure HTTPS, that is SSL code 443. In order to do that. If you want to have it on your EC2 instance, in that case you will need to integrate it with your applications like Apache or Nginx, your web server applications. So I believe it's always better to have this kind of integration at load balancer, because then you can easily configure your auto scaling or horizontal scaling kind of thing. Is it okay? That's, I believe I have already answered. Is it good to install? So how it will benefits for application? Not clear, very much clear with the question. Sorry, which flavors of Linux has to be used for AWS? So there are multiple flavors available, like CentOS is there, RHEL is there, Ubuntu is there, and if you want to have any customized one, then you can do that also. So there are APIs from where you can create image of your local instances and then can import it over AWS, and there you can use that. Then there is the question, what makes S3 so cheaper? So believe me, even I don't have any answer for this, but there are storage services on AWS itself which are much more cheaper than S3 also. So there is one variant of S3 called RRS. It's some redundancy storage, and the pricing is $0.024 per GB per month. Similarly, you can have Glacier. The pricing here is 0.01, but again, dollar per GB per month. But again, the retrieval period is pretty much slow, so you cannot directly access anything from Glacier. So you need to first import it to S3, and then from there you can access that particular backup. What is the difference between horizontal and vertical scale? So by vertical scaling, I mean a single instance where you are increasing the resource, the capacity of single instance. So as I said earlier also, if you are running with instance with 3.75 GB of RAM, and then you can very well scale it up to 7.5 GB RAM or to any other configuration. So this is vertical scaling. In horizontal scaling, you will have multiple instances. Rather than increasing the resource, we are now increasing the count, the number of instances, and then sharing the load accordingly. So that is the difference between the two. How to decide which type of instance type we have to use in particular website? So how to decide that which type of instance type we have to use in the particular website? So with instance type, if you are asking about the instance capacity, then yes, you have to analyze it first. If you are already having a running application, and if you are otherwise you are going with new application, then you can start with some good configuration, monitor it 4 or 5 days, and if you find that the servers are overutilized or underutilized, then accordingly you can scale up or scale down the configuration. I think that's once the free AWS services are about to cross the limits, will I alert as I want to try some? Yes, in that case, you need to configure the alerts for yourself. Otherwise, it is pretty much clear from the billing console which AWS provides that it is getting beyond that or not. can I set up Cloudera on AWS for big data solution? Yes, of course you can do that. You can set up the Cloudera nodes name as well as data nodes on AWS EC2 instances. Is it good to install DB and application servers with sudo users on EC2 machine, or good to go with non-sudo users? So it's always better to go with non-sudo users if your application allows for that. Guide me for load balancing in EC2 instance. This is asked by Mr. Tahir Mahodia. So it's pretty much simple. I mean, you can configure, you can procure 2 instances first of all, then you need to procure AWS load balancer, then within that load balancer you need to mention both the instances. You can mention it via their instance ID. Then you need to create some health check configuration. Suppose I want that if within 5 seconds for 5 cycles I have not received any response from the HTTP protocol or TCP protocol of that instance, in that case this particular instance can be declared as dead or unhealthy. So these kind of checks you can create. Then you can have port forwarding. You need to create that port forwarding, that anything which is coming on port 80 of my EC2 in my AWS Elastic load balancers, that will go to port 80 of my application, or port 443 of load balancer to port 80 of EC2 instance. Then you have to create a security group. I mean, you have to include the security group of your load balancer to the security group of EC2 instance. So you'll get the nodes as such on AWS side. Otherwise, the process is pretty much similar, which I have explained. So now we are running out with time, so we will mail answers to the remaining queries. Thank you. Deepika, over to you.
Thank you, Rajat. Thanks for conducting this insightful webinar. I'm really thankful to our guest speaker for conducting this webinar today. It was indeed a great session. I would also like to thank all of you for your support in making this webinar a huge success. The recording of this webinar will be available on techgig.com very soon. Thank you, everyone. Thanks for your time.
Thank you so much.
Thanks. Bye-bye.